Welcome surfers, it is Joel and this is Rustlers Atom 2.9. In today's video we talk about interior mutability in Rust. If you haven't subscribed to this channel yet, maybe this is the perfect time to do it to support Rustlers and to support my job. In Rust, rule number 1 is that you cannot mutate data behind a shared immutable reference. It's a strict rule, and the compiler strictly forbids it to prevent data races condition. But what if you need to do something like this? What if you have, for example, a struct that is logically immutable to the outside, but inside you need to update something like an internal counter or a cache or a log. This specific pattern is called interior mutability. Rust provides two safe wrappers that let you say bend the rules by moving the borrow checks from the compile time to the runtime. First, let's take a look to the first of these two wrappers, the cell wrappers. Now I can create a struct called the sensor that have an ID field, a string, and a counter field that is unsigned integer 8-bit. Okay. Now, if I need to mutate this counter using an immutable sensor, I need to wrap my U8 into something else. I import standard cell for the standard library from the standard library, and now I can wrap our counter with cell. Cell never gives you a reference or a pointer to the inner data. Instead, simply lets you to copy the value, the inside value, out, modify this value, and swap it back in. Now, for example, we can implement the mutation of this counter. So, implement sensor, we need a function called increment to increment the counter. This function uses an immutable reference of our sensor, so reference of self. Okay, now inside the function we need to get a copy of the value, okay, and we can increment by 1 this is a copy. And now we can set the value back in the counter with the set function. Perfect. Now I can simply create a sensor called S. Inside this sensor I have an ID, sensor 1, and I initiate the counter that is a cell with inside an integer that in this case is 0. Okay, now the sensor is immutable, but we can change the counter. Simply call the increment function. To prove this, I can print with print line the value of the counter. So something counter is something. In the first place, I can insert the ID of the sensor, s.id, and in the second place, I can insert the counter. I get the counter from the cell. Okay, let's give a try to this code. I forgot something. Okay, this is one. Okay, I forgot this and this. Perfect. Okay, as you can see, the sensor 1 have an internal counter incremented by 1. If I call increment multiple time, okay, so s.increment and s.increment, our counter now is 3, and all of these with an immutable sensor S. Okay, but what if you have data that isn't copy, like our unsigned integer, but is something like a string or a vector? In this case, we can't use the cell wrapper, but we use the RefCell wrapper. So I can use standard cell RefCell, and I can create another struct called, I don't know, super sensor. In this struct I have an ID that is a string. Okay, and I have a vector of values. Each values is an integer 32. Okay. In this case, if I need to mutate values in an immutable supersensor, I need this wrapper, RefCell. Okay. RefCell tracks your borrows dynamically while the program is running. This wrapper maintains an internal counter that count how many readers or how many writers using this data. On a RefCell, you can use the borrow function to get a shared reference and the borrow mute function to get a mutable reference. So now I can implement super sensor and inside this implement I write the read function to read a value with this sensor. Also in this case we use an immutable reference of the super sensor, and we ask for a mutable borrow at runtime. So let mutable vector v equal to self values borrow mute. Okay, and now we can push something inside this borrow mute. So v dot push, we in any case push the value 1 just for the example. Okay, now let S2 equal to super sensor with ID equal to string from sensor 2 and values is a RefCell with inside a new vector. The compiler understands what is the type of this vector using as a reference the first insertion of data inside the vector. Okay, now I can read a couple of values with this sensor, and just to see the result I print, like in the previous case, something values are. We use the debug view of the data. Perfect. The first value is the ID, s.id. The second value is the borrow, in this case because it's not mutable, of values. Okay, so we see the borrow function here and the borrow mute function here. Okay, let's try this code. Values borrow, what is the name? S2, sorry, this is the problem. And we forget again something. Perfect. As you can see, the sensor 2 values are 1 and 1 again. So also in this case we mutate the internal state of an immutable struct, super sensor. In this case we use RefCell because a vector don't implement the trait copy. But with a simple U8, something that implements the trait copy, we can simply use cell. If you violate the borrowing rules, for example, like trying to call borrow mute while someone else is already borrowing the data, in this case the compiler won't stop you, but instead the check is due at runtime, so your program will simply panic and crash at runtime. For this reason, the suggestion is to use these wrappers spiraling, because they come with this problem of stability of the program and come with a small performance penalty. For this video it's all. See you in the next Atom. Don't forget to like, to subscribe to this channel, and as always to keep your thinking cap on.